Hello, good day everyone. So I am discussing the procedure for stress analysis. Actually, this is only a review from your previous topic. So the stress analysis of an actually loaded member of a structure involves the following. First is equilibrium analysis. In equilibrium analysis, you must find first the external reactions using a free body diagram of the entire system. So, katunayan, si free body diagram, yan yung pinaka-focus or yung pinag-aralan natin noong Engineering Mechanics 1, which is yung statics of rigid body. So, using a free body diagram is one of the essentials when solving mechanics problems or engineering mechanics problems. Kasi kung wala si free body diagram, you won't be able to solve for the external reactions or the unknown loads na kailangan mo bago mag-solve ng situational or actual problems in mechanics of materials. So by the use of the method of sections, we will solve for the actual force P in the member. So bakit sa method of sections? Kasi sa method of sections, kailangan nating ipakita yung internal reactions dun sa isang structural member or solid material. And not only that, pag nag-method of sections kasi tayo, magagamit natin yung method of sections para magkaroon tayo ng easier way to solve for reactions. Kasi hinahati natin yung material into sections, para mas mapaunti natin yung unknowns na ilalagay natin sa free body diagram natin, So the method of sections introduces an imaginary cutting plane isolating a segment of the structure. The one I discussed nung itong nakaraan, or from your previous topic. So tinuro ko na kung paano construct ng cutting plane, and kung paano gawin si method of sections. So si cutting plane, ulitin ko, or cutting planes must include the cross-section of the member of interest. So kung nasaan yung hinahanap mo or sinosolve mo na actual force P or yung load na hinahanap mo para dun sa may solution mo for the current problem, yun yung i-consider mo, yung member of interest. So, maipapakita mo yun through the method of sections. So, after nun, it then can be found the actual force acting in the member from the free body diagram of the isolated segment because it now appears as an external force on the free body diagram. So, bakit nga ba siya mag-a-appear na external force after you cut the material or the member through the method of section or by the use of cutting plane? Gaya nga ng diniscuss ko last week or last topic, kapag ang isang section in-applyan ng load externally sa surface niya or sa cross-section niya, kapag kinat mo yan, makikita mo yung internal parts niyan ay nagre-react dun sa external loads. Yun yung tinatawag natin na internal forces. Okay? So, kapag nga naman biniyak mo siya or sinection mo na yung material, in that manner, lalitaw ngayon itong si internal load na nasa loob ni material or ni solid material. So, in that manner, you can now consider the member of interest as the free body diagram for your problem. So, next is number 2, computation of stress. So, after you solve for the actual force P or the unknown loads, you will then proceed to actually computation of the stress. So first is obtain the average normal stress in the member. Using our formula, of course, stress equals to force over A or stress equals to P over A. So yung A daw, capital letter A, is the cross-sectional area of the member at the cutting plane. So, I already told you how to analyze kung anong cross-sectional area yung gagamitin mo. But for your benefit, ulitin ko lang ulit yung explanation para doon. So, kung saan tumama yung force, P, or kung saan nag-a-act yung load, P, kung saan cross-section nag-a-act yun yung kukunin mo na cross-sectional area. Okay? So, proceeding in letter B. So, in slender bars, stress or our formula stress equals to P over A is the normal stress. So, if the section is sufficiently far from applied loads and abrupt changes in the cross section. Okay. So, what do you mean by slender? No? Slender means payat in Tagalog. So, yung P over A daw na yun is already the normal stress if the section is sufficiently far from applied loads. Okay. And the last is our design considerations, obviously. So, in designing materials or members of structures, the computed stress must be compared with the allowable stress. So, ano nga ba si computed stress? So, I already discussed on our previous topic what is computed and allowable stress. But again, computed stress ay yung na-compute nyo from step 2, which is P over A or stress equals P over A. Siya yung resulta nung external force P or nung loads na na-apply dun sa material. From the word itself, computed. Siya yung na-compute nyong stress from the external load na sinolve mo naman from step 1, from equilibrium analysis. Okay? By the principles of statics of rigid bodies or equilibrium mechanics. Okay, and this allowable stress naman, siya yung stress na ina-allow mo para sa material. Ibig sabihin, siya lang yung amount or yung value ng stress na pwedeng mag-apply or pumasok dun sa material. Allowable stress is also called the working stress for design purposes. So, yung dalawa na yan yung pagbabasehan mo when you are solving for the strength capacity of your material or a structural member. You'll know why when we discuss about the topic in factor of safety. When we come to our topic, stress-strain diagram. Okay. So, to prevent failure of the member, the computed stress must be less than the working stress. So, para maiwasan nga natin yung failure or yung pag-collapse ng isang member or ng whole structure itself or any material, yung computed stress daw must be less than the working stress or the allowable stress. Kasi nga naman, kapag sumobra dyan yan, or pumantay, or nag-equal yan, yung computed and yung allowable stress, may possibility na mag-deform siya permanently, or much worse is failure or total collapse, breaking point. Okay? So, ayun. Yun yung step-by-step procedure for stress analysis. So, napakasimple. Tandaan, the use of equilibrium by equilibrium equations, obviously, and applying the principles that you've learned in statics of rigid mechanics last semester. And the next step is the computation of stress using our formula P over A. That is the foundation formula. Actually, lahat naman ng formula na in solving for stresses is derived from P over A. So, nababago lang sila. Actually, kapag iba yung load o kaya naman iba yung cross-sectional area. And finally, design considerations. So, you'll compare computed stress and the allowable stress, also known as the working stress, to select the strength capacity of that material you are designing or considering. So, notes on the analysis of trusses. So, si trusses, kung sa mga hindi nakakaalam, si trusses ay yung nakikita natin sa mga bubungan ng bahay natin. So, siya yung mga pinagkakapitan ng mga purlina na tinatawag or purlins. Okay? Siya yung pamakuan or balangkas kung tawagin ng iba, no? And makikita nyo rin ang trusses sa ating mga steel bridge. One example is yung steel bridge dito sa may tulay ng Kalayungan. Okay, so that is a truss bridge. Okay, so that's one example of truss. So notes lang naman to. So the usual assumptions made in the analysis of trusses are, so ito yung assumptions when you are analyzing trusses. So number one is the weight of the members are negligible compared to the applied load. So we are neglecting the weight of the member compared to the applied loads. So ano yung applied loads? Yun yung ibang term kay external loads. So sila yung mga load na nag-a-act externally doon sa members ng truss. So number two is joints behave as smooth pins. So smooth pins, So smooth pins, they are free of translation. So smooth pins, ginagamit din yan as support, 'di ba? Na-discuss natin nung statics of rigid bodies. And number three, finally, all loads are applied at the joints. So paano ba yun? Yung all loads are applied at the joints. So let me draw. Okay. Okay. So let's say this is a joint of a truss, Sabihin natin this is joint A. Okay? And kinuha mo to sa isang whole truss, So, sinection mo siya halimbawa. Kinuha mo yung joint A. Yan. So, let's say itong member na to is papunta kay joint B. And yung member na ito is papunta kay joint C. And then you'll have segment AB and segment AC obviously. Tapos, meron kang angle theta dito, So, kapag in-analyze mo tong joint ito, after considering the whole structure of the truss as a free body diagram, obviously, you'll have reaction here or a reaction here. Actually, this is the vertical reaction at point A. And you'll have the horizontal reaction at point A or joint H. Bakit? Because ang support mo dito kay joint A or at this point is a hinge. Okay? So, you know why, And kung makikita nyo, sabi, all loads are applied at the joints. So, lahat daw ng load na yan ay nag-a-act dito kay mismong joint or sa point na ito. So, itong system na to ay kinoconsider mo as a concurrent force system. Kung titignan mo mabuti. So, ito, si force AB, Halimbawa, ito yung assumption mo kay force AB. And dito kay force AC, may assumption ka din, So, kung ang assumption mo, halimbawa, para kay force AB is a tensile force, and ganun din kay tensile C, ay kay force AC. So, ang assumption mo rin kay force AC ay tensile. Kapag in-analyze mo yan or sinolve mo yung value ng forces na yan using the equations of equilibrium, tapos nag-negative or naging kumontra dun sa assumption mo yung sign nitong value ng forces na to. Halimbawa, kay segment AB, ano? Sinolve mo yung force dyan. Tapos, ang nasolve mong force is a negative 20. Kamo na lang, ano? So, this is an example lang, ano? So, kung nakita nyo, negative 20 yung force na lumabas. Pero, ang assumption mo is a tensile force itong nag-act kay AB. Babaliktarin mo lang yan ngayon, di ba? Kung naaalala. So, this is also equal to 20. Gagawin mo lang siyang compression. Babaliktarin mo lang siya, no? So, pag compression, papunta dun sa may mismong point kung saan sila nag-a-act. Okay? So, example lang naman yun. So, bakit daw sila nag-a-act at the joints? Kasi kung titignan mo mabuti or kung pag-aaralan mo mabuti bilang estudyante and bilang engineer na rin, no? So, consider yourselves already as an engineer. Tignan mo yung mga trusses natin. So, saan ba sila nagkakadikit-dikit or nagkakatugon-tugon? Diba dito sa may joints? So, they are connected using bolts or welded connections. So, ina-align sila dyan. No? Diyan sila nagkakasama-sama sa joint na yan. And kapag may pumasok na load dito, like for example, this one, itong kay segment AC, halimbawa, tensile force, saan ba nagre-react yan? Obviously, dito sa joint. Okay? And kung halimbawa naman, itutuloy mo to, halimbawa, i-consider natin dito si joint B, ano? Joint B. Okay. Diba, ang assumption mo sa una is tensile force na nag-act kay joint B. Well, kapag kinuha mo rin yung joint B, like for example, ganito itsura niya, no? Nung truss. Bawa A, C, tapos D, ano? So, kapag in-analyze mo, kung ano yung analysis mo dito sa una, no? Kung hindi mo pa kino-correct yung signs nila and yung assumption mo, bawa, compression yung lumabas dito, tapos hindi mo pa siya binabago, pero you are using the sign, ano? Or the negative sign na na-solve mo dito sa may value ng force AB. Ang ilalagay mo pa rin dito kay joint B is a tensile assumption, ano? Pero, ulitin ko, you will use the sign, ano? Or yung computed value ng force dito kay AB. Okay, and then nag-assume ka ulit dito kay BC and BD. So, ganun lang yun, ano? Doon sila nagre-react sa joints kasi doon sila connected. And once you consider a joint, lahat ng force na nag-act doon or yung system of force na yun is a concurrent force system. So, yun lang naman. So, you'll analyze the joints using equations of equilibrium, obviously. So, finally, under these assumptions, each member of the truss is an actually loaded bar. Okay? So, bakit siya actually loaded bar? Kasi dyan nagtatransfer yung loads na dinadala, no? Na dinadala. Halimbawa, may bubong ka. Actually, yung bubong, sasaluhin niya muna yon and then, matatransfer yan as actual loads dito kay trusses. So, wala pa naman tayo doon sa may mga design ng roofing, ganun, ano? Hindi ko pa ituturo yon. So, that's not part of our subject, actually. So, these internal forces in the bars can be obtained by the methods of sections or the methods of joints. So, ayun. So, you'll have to review or study or continuously practice the method of sections and method of joints. So, that is all for the discussion for the procedure for stress analysis. So I hope you learned something. So thank you everyone.